r power 4. So this becomes 2. This is equal to 5r square. So that the calculation is now very simple. We need to only remember what is divergence of f. So this is a 1996 problem. A vector field A of R is given to satisfy divergence of A equal to 0 and Laplacian del square A of the vector field is equal to 0. From these, it necessarily follows that A vector is equal to 0, curl of A is equal to 0, curl A is equal to 0, or A vector is a constant. If you remember the fifth identity, it is a direct question. So what is curl of curl A by definition, which is gradient of divergence of A minus del square A. So what is given? Divergence of A is 0 and del square of A is 0. So that implies this is equal to 0. So curl of curl A is equal to 0. So that is the correct answer. Then one more direct question. This was asked in 1990. Divergence of where E or cap is the unit vector along radial direction. Is so what is the answer? It's a direct question. So that is the radial form, the final identity which we looked at. So del dot r vector by r cube, which is same as divergence of r cap by r square. So instead of r cap, they are denoting a notation E r cap. So that is equal to 4 pi delta of r. So that is the correct answer. In 1999, the function r power n into r cap, where r is greater than 0, where R refers to spherical coordinate system is an irrotational vector for n equal to -2, a solenoidal vector for n equal to -2, or an irrotational vector for n equal to -3, and finally a solenoidal vector for n equal to -3. So what do we need to evaluate? So here, so which are all the answers which are not going to be correct is A and C, because the given vector field is only a function of position R alone. So because of that, it will be irrotational for any n, irrespective of any value of n. So what do we need to evaluate now? So divergence of R. So that alone one need to calculate for R power n R cap. What is this equal to? 1 by R square dou by dou R of R square into R power n. So this is the rth component, radial component of the given vector function. So theta part and phi part are 0. So when will this be equal to 0? So this will be equal to 0 whenever you have a constant function here. So that will be satisfied only when n equal to -2. So that will give you a factor 1. So which is the correct answer then? So it's a solenoidal vector for n equal to -2. If A vector is equal to x Ex cap plus y Ey cap plus z Ez cap, then del square of A vector equals 1, 3, 0 and -3. So what is being asked is del square of A vector. So we need to find Laplacian of the x component of the given vector field, Laplacian of y component of the given vector field, plus Laplacian of z component of the given vector field. So which is uniformly del square Ax, which is 0 because it involves only function of x. Similarly, this is same for del square Ay, this is same for del square Az. So what is Ax? Ax is x, Ay is y, and Az is z. So because of that, the answer is 0. (2005) if a vector field F is equal to xi cap plus 2y j cap plus 3zk cap, then curl of curl F is 0 is equal to I cap 2 j cap or 3 k cap. So how do you go about solving this? You can straight away calculate curl F, and what you will find is it will be 0, and 0 of any function which if you take again, that will be 0, or otherwise you can also use this identity curl of curl is equal to gradient of divergence of F minus del square F. What is divergence of F? So that will give you 1 plus 2 plus 3, so that will be a constant number. If you take gradient of that, this will be equal to 0. Since the components for del square fx plus del square fy plus del square fz, so into x cap plus y cap z cap. So you need to calculate del square of fx, which will be again second derivative with respect to x, that will be 0. Similarly, del square fy, which will again be equal to 0. Similarly, del square fez corresponding to the z component of the given vector field, that will also be uniformly 0. So because of that, curl of the given vector field is 0. Finally, in 2013, for a scalar function phi satisfying the Laplace equation del phi has